Hi everybody, today we're going to be looking at modulus inequalities. So that kind of launches off some of the work we've been doing in modulus equations, but there is going to be some key differences that we need to take into account. So if we think about this inequality that the modulus of x is less than 5, what values of x would satisfy this equation? So if we think about something like x equals 4, then the modulus of 4, is just 4, and that's definitely going to be less than or equal to 5. However, if we take a negative number, let's say something like negative 2, well, the modulus of negative 2 is going to be 2, which is less than or equal to 5 as well. So 4 and negative 2 satisfy this equation. But how about we go something that's even more negative, maybe like negative 7. Now the modulus of negative 7 is just positive 7, which is greater than or equal to 5, and so it's not all negative values that will work. It will only be the ones between negative 5 and all the way up to positive 5. So only the values between 5 and negative 5 will satisfy this equation, because once we get more negative than negative 5, once we go lower than negative 5, well then the modulus takes away the negative sign, and so we have numbers that are greater than 5. So I guess what we could say is that if the modulus of x is less than or equal to 5, then we're really saying that x has to be less than or equal to 5, but greater than or equal to minus 5. And so we get this setup of these this equality that actually has two inequalities in one. Now, it's okay to do that because it still satisfies the conditions. X is less than or equal to 5 and x is greater than or equal to minus 5. It's just saying two different inequalities and expressing them in one. Now, what about modulus of x greater than 5? Well, any positive number greater than 5 is going to work. Now, I've got a hollow dot because I'm not including 5 because this is strictly greater than. And so any positive number greater than 5 is going to work. But if I think about it, what about any negative number? Let's say negative 10. Well, the modulus of negative 10 is 10, and that's going to be greater than 5 as well. So anything less than minus 5, when we apply the modulus to it, it's going to take away the negative, and so that's going to be more than 5 as well. So in this case, the modulus of x being greater than 5 gives us two inequalities, which is a lot harder to represent in one this time. So it tells us that x has to be greater than 5, or x has to be less than minus 5. And we saw this in the properties that we talked about. This is property 8 from the properties we had last lesson. So if the modulus of a is less than or equal to b, then a is less than or equal to b and greater than or equal to minus b. If the modulus of a is greater than or equal to b, then either the a has to be less than or equal to minus b, or a has to be greater than or equal to b. Okay, alright, so 2x take 4 is less than or equal to 4. So if I've got 2x take 4, the modulus of that less than 4, then I can say, okay, 2x take 4 has to be less than 4 and greater than minus 4. And what I can actually do is I can go through and I can work through each of these. So let's take my equation 2x take 4 is less than 4. So adding 4 to both sides gives me 2x is less than 8, so x is less than 4. I can also say that 2x take 4 has to be greater than minus 4. Adding 4 to both sides gives me 2x is greater than 0, so x is greater than 0. And so potentially putting this back into one inequality, or two inequalities expressed as one, x has to be less than 4 and greater than 0. Okay, 3 take 2x, modulus has to be greater than or equal to 1. Gives me my two inequalities. The first one says that 3 take 2x has to be greater than or equal to 1. So, in this case, taking 3 from both sides gives me minus 2x has to be greater than minus 2. As I divide by minus 2, my inequality needs to reverse. So I get less than or equal to. The minus 2 is cancelled there, so x has to be less than or equal to positive 1. The other thing it tells me is that 3 take 2x has to be less than or equal to minus 1. Taking 3 from both sides tells me that minus 2x has to be less than or equal to minus 4. I now also need to reverse my sign, so minus 2x has to be greater than or equal to minus 4, dividing by minus 2 on both sides. Notice that I only change my sign when I actually divide by minus 2. So you've got to be very articulate in writing the reversal of sign at the right spot. So then x is greater than or equal to 2. So what we've seen here, that x is less than or equal to 1 and greater than or equal to 2. So those two inequalities are my solution to that second one. If I look at this third one, it's a quadratic, but nothing really changes. The modulus of x squared take 5x being less than 6 tells us that x squared take 5x has to be less than 6, that's my first one, and x squared take 5x has to be greater than minus 6. Okay, so we've got quadratic inequalities. X squared take 5x take 6 has to be less than 0. So I start by finding my roots. So x squared take 5x take 6 equals 0. So if I factorize that, I get x, take 6, x plus 1 equals 0. So x is equal to 6 and minus 1. They're my roots. Now if I draw the sign diagram, I'm going to have a root at minus 1 and a root at 6. And because my coefficient of x squared is positive, I've got a concave up or upward facing quadratic. So it's positive beyond 6 and less than minus 1. And we want that. No, we don't. We want it less than 0. So that's x less than 6 greater than minus 1, expressing those two inequalities as 1. Okay, now what about this one? Well, x squared take 5x plus 6 has to be greater than 0. So in this case, it's x, the factorization is x take 3, x take 2. So my roots are 3 and 2. Drawing my sign diagram again and putting my roots of 3, 3 is a higher one, so it'll be 2 and 3. Again, the coefficient of x squared is positive, so it's upward facing. So I'm positive on the outer edges and negative in the middle, and this time I do want it greater than 0. So we get that x has to be greater than 3, and x has to be less than 2. Okay, so that's modulus inequalities, and we'll talk about them a bit more in lesson and also talk about how to solve them graphically, as shown as the last example there.